Hello students, welcome to aimstoday online classes. This is a chemistry session. Here we are discussing about the structure of the atom, chapter structure of atom. In the earlier sessions we have seen about different fundamental particles and their discovery, their properties and the arrangement of these fundamental particles, different models of atoms expressed by different scientists. We have seen these all concepts. Now in this session we are going to see a practice sheet which is related to this chapter. We are going to see practice sheet 2. Already practice 1 we have completed. In this practice sheet 2 we are going to have different kinds of questions like multi-correct answer, comprehension, matrix matching type questions and analytical approach questions. In this way different kinds of questions we are going to see from this practice sheet 2. Okay, let us start this. First let us go through the multi-correct answer type questions. See the first one. Which of the following statements are correct for Bohr's model of an atom? Yes, Bohr's model has proposed certain postulates about the structure of atom. See, some statements are given here which are correct about this Bohr's model. See, the first statement given: the nucleus of an atom is situated at its center. Isn't it? Yes, nucleus is situated at the center of the atom. This is correct. Next one, the electrons move in circular orbits. Of course, this is also correct. Bohr told that electrons are revolving around the nucleus in imaginary circular orbits. Next, electrons jump from one orbit to another orbit. Of course, it also happens when electrons gain or radiate energy. They jump from one orbit to higher other orbits. If they absorb energy, then they jump to higher orbits from their original position. If they release or radiate energy out, then they jump into lower orbits. It happens. An electron neither loses nor gains energy when it jumps from one orbit to another orbit. This is incorrect, isn't it? Because electrons jump from one orbit to another orbit when energy changes occurs only. If electrons gain energy, then it jumps to higher orbits. If it loses energy, then it jumps to lower orbits. So energy changes occurs when electrons jump from one orbit to another orbit. So this statement is incorrect. So these three are correct statements about Bohr's model. Okay. See the next question. Which of the following electronic configurations are incorrect? See the configurations here. First one, beryllium. We know the beryllium atomic number is 4, but they mentioned here 3. So it is incorrect configuration for beryllium because atomic number of beryllium is 4. So it should be 2 comma 2 configuration, but they mentioned here 2 comma 1. So it is incorrect configuration for beryllium. See next is sulfur. We know sulfur atomic number is 16. Of course it is given correct. Now according to Borsbury scheme, first shell can accommodate 2 electrons. It is correct. Second shell can accommodate a maximum of 8 electrons. So after filling the second shell with complete 8 electrons, then only electrons enters into third shell, isn't it? But here what happened? Second shell is filled with 6 electrons only for sulfur. The remaining 8 electrons enter into third shell. It won't happen, isn't it? It is incorrect configuration. What should be actually for sulfur, as it has 16 electrons, there should be 2 electrons in the first shell, and next there should be 8 electrons in the second shell, and the remaining 6 electrons will be in the third shell. So it should be 2 comma 8 comma 6, but they mentioned here 2 comma 6 comma 8, which is incorrect. See the next one, phosphorus. Atomic number of phosphorus is 15, correct. So it has 15 electrons. Now 2 comma 8 comma 5 is a correct configuration because first shell can accommodate 2 electrons, second can accommodate 8 electrons, and the remaining electrons will go into the third shell. 2, 8, 5 is correct configuration. Next, C for sodium. Yes, sodium atomic number is 11. It has 11 electrons. As it is having 11 electrons, first 2 electrons enters into first shell. It is correct. And next, second shell can accommodate 8 electrons of maximum. So out of the remaining 9 electrons, 8 electrons enters into second shell. So after 2 it should be there 8. But it is represented here, all the remaining 9 electrons are in the second shell. Is it possible? No. Second shell cannot accommodate 9 electrons. So sodium configuration is incorrect. Now what they're asking in the question, which of the following electronic configurations are incorrect? So first one is incorrect, second and fourth. These four are incorrect configurations. This is correct configuration. Okay. Now the answer will be A, B, C, D. See the next question. Which of the following statements are true? See the statements. First one. Most of the space in an atom is empty. Yes, it is correct. Atoms are having mostly empty space. Total number of neutrons and protons is always equal in a neutral atom. Is it correct? No. Okay, it is correct only. So first statement is correct. Second statement is incorrect. What is that? The total number of neutrons and protons is always equal in a neutral atom. No, we cannot say this. Because some atoms they have number of protons and number of neutrons equal. But most of the atoms they do not have these two in equal number. For many atoms, number of neutrons and protons is not equal. Mostly, number of neutrons is being 1 or 2 more number than that of protons. So it is incorrect statement. See the next one. The total number of electrons and protons in an atom is always equal. Can we say this? No. This is also incorrect. Because total number of electrons and protons is equal in neutral atoms. But it is not always equal, because sometimes atoms they lose electrons, or sometimes they may gain electrons also. In the formation of chemical bonds, atoms either lose or gain electrons. By that, the number of electrons will be changed. So then number of electrons won't be equal to number of protons. So we can say here number of electrons is equal to number of protons only in the neutral atoms. It is not always equal. Okay. Next one. The total number of electrons in an orbit can be calculated by the formula 2n square. Yes, it is correct. According to Bohr-Bury theory, it is given a statement that the total number of electrons that can be accommodated in an orbit is given by the formula 2n square. So it is correct. Now they are asking to find out the correct statements. So A and D are correct. Okay. Next question. Which of the following are isotopes of hydrogen? Yes, how many isotopes are there for hydrogen? There are 3 isotopes. What are those? Protium with 1 proton and 1 electron. Deuterium with 1 electron, 1 proton and 1 neutron. Next, tritium. Tritium is a radioactive isotope of hydrogen with 1 electron, 1 proton and 2 neutrons. So in this way, these 3 are the isotopes of hydrogen. First, did you remember what is meant by isotopes? Isotopes means atoms of the same element with a different mass numbers. Atoms of the same element with the same atomic number but different mass numbers are called isotopes. So here hydrogen has 3 isotopes: protium, deuterium and tritium. These 3 are the isotopes of hydrogen. Next, let us see here comprehension passage type questions. First, see the comprehension paragraph given. The particles that make up the atom or the particles that are smaller than the atom are called subatomic particles. The three main subatomic particles that form an atom are protons, electrons, and neutrons. These three are called fundamental particles also. Okay, these are the main subatomic particles. Why we call these main means there are around 100 types of subatomic particles existence in the atoms. So out of those all, these three are main subatomic particles. What are those three? Electrons, protons, and neutrons. Now let us see questions regarding this. By whom was the neutron discovered? Yes, who discovered neutron? He was James Chadwick. James Chadwick discovered neutrons. Next, which of the following has a charge of 1 unit positive charge and a mass of 1 AMU? Yes, out of three fundamental particles, the particle with 1 unit positive charge and 1 unit mass, that is 1 atomic unit mass, is proton. Proton is having these quantities. Whereas if you see for electron, it has 1 unit negative charge and no mass actually to say. It is having negligible mass. If you see in case of neutron, neutron has 1 unit mass, that is 1 atomic unit mass, but no charge for it. But here the particle with 1 unit positive charge and 1 unit mass is a proton. Next, canal rays are nothing but positively charged particles. Anode rays are also called as canal rays. They are positively charged particles. The smallest canal ray is proton. Okay, canal rays are positively charged particles. Next, one more comparison is given. See the statement given here. The frequency, velocity of light and wavelength of an electromagnetic radiation are related one to another. The other commonly used quantity, especially in spectroscopy, is wave number. So these are all related to one another. Wavelength, frequency, wave number, velocity of light. These are characteristics of electromagnetic radiations. These all are related to one another. Now let us see the questions related to this. See the first one. Which of the following relations are correct? Certain relations are mentioned between these characteristics of electromagnetic radiation. Identify which are correct statements or relations. Frequency into wavelength gives velocity of light. We have a relation between frequency and wavelength. That is, nu is equal to c by lambda. Isn't it? So if you write frequency into wavelength, that is equal to velocity of light. This is correct. If you see energy is equal to, what formula we are having? E is equal to h nu. It is a Planck's equation, it is called. E is equal to h nu, where E represents energy of the radiation, nu is frequency of radiation, and h is the Planck's constant. So energy is equal to Planck's constant into frequency. This statement is also true. Next, frequency is equal to velocity of light into wave number. Already we have seen this relation here. Frequency is equal to c by lambda. We know frequency is equal to c into, we can write this as 1 by lambda, isn't it? 1 by lambda represents wave number, because wave number is the reciprocal of wavelength. So in the place of 1 by lambda, we can write nu bar. Now it becomes nu is equal to c into wave number. So frequency is equal to velocity of light into wave number. So this relation is also correct. What it becomes now? All these three relations are correct. Fourth is the correct answer. Okay, next one. The wavelength of a radiation is 97,540 centimeters. Calculate its frequency. Observe once, one quantity is given and asked to calculate the another quantity. If we know the relation between these two, we can find out. What is the relation between the wavelength and frequency? We have nu is equal to c by lambda, where nu is the frequency, c is velocity of light, which is a constant, and lambda is the wavelength. Wavelength is already given in here. If we substitute those two values of velocity of light and wavelength, we can calculate frequency. See, wavelength lambda is equal to 97,540. Now, this is given in centimeters. So, velocity of light is also taken in the same system of units, that is in the centimeters per second, which is equal to 3 into 10 to the power of 10 centimeters per second. So, substitute those values, do the calculation, we get it as 3.07 into 10 to the power of 5 second inverse. This is the frequency we get. So just if you know the relation between those two quantities given, we can find out the unknown one. Okay, next. A light of any electromagnetic radiation travels in vacuum or air with a speed of. What is the velocity of any electromagnetic radiation? It is considered that all the electromagnetic radiations travel with the same speed, that is speed of light. It is equal to 3 into 10 to the power of 8 meters per second, or 3 into 10 to the power of 10 centimeters per second. Where is it given? Here it is. Okay, that is the velocity of all the electromagnetic radiations. One more common property is these all electromagnetic radiations travel at the velocity of light, and even they do not need any medium for their propagation. Means they can travel through the medium, and even they can travel through vacuum also. Okay, next, let us see matrix matching type questions. See here, fundamental particles are given and their characteristics are given in the column 2. See proton, what charge it is having? We know protons are having positive charge. They carry 1 unit positive charge. If we see electron, electron is having negative charge, 1 unit negative charge. What about neutron? Neutrons are having no charge. We can say they are neutral particles. And next, nucleus consists of. What does it contain? Nucleus consists of protons and neutrons, which we call them together as nucleons. So out of these nucleons, protons are positively charged particles, whereas neutrons are neutral particles. So finally, nucleus is consisting total positive charge also. It contains protons and neutrons. At the same time, it carries a positive charge, which is because of protons. Okay. These are matching observance: protons positive charge, electrons negative charge, neutrons no charge or neutral charge. Nucleus consists of protons and neutrons, and it carries positive charge overall due to protons. Okay, now let us see one more next. One more matching here. Here, characteristics of electromagnetic radiations are mentioned here, and in the other side, their units are mentioned. Try to match these with units. See the first one, frequency. It is defined as the number of waves passing through a point per second. So the units of this frequency will be per second or cycles per second or hertz. Where is it? Frequency units are second inverse. And of course we know this frequency is inversely proportional to wavelength also, because we know the relation between frequency and the wavelength as nu is equal to c by lambda. This is a relation, isn't it? So if you observe here, frequency is inversely proportional to wavelength. So this is related to this also. Next, wavelength. Wavelength is defined as the distance between the two adjacent troughs or two adjacent crests of a wave. As it is a distance, what will be the units? Meters, centimeters, micrometers, angstroms. These all will come as the units for wavelength. See, out of these, here they are mentioned centimeters. Okay, that's a matching for wavelength. Next one, wave number. Wave number is defined as the reciprocal of wavelength. So its units will be centimeter inverse. And at the same time, as it is being reciprocal to wavelength, so it is inversely proportional to wavelength also. Next matching, velocity of light. Velocity of light, as it is velocity, its units will be centimeters per second or meters per second. Okay, this is a matching. Observe once the matching. Frequency second inverse, wavelength centimeters, wave number centimeter inverse, velocity of light centimeters per second. Okay, out of these, frequency and wave number are inversely proportional to wavelength also, right? Let us see next about statement type questions. See the first question. According to Bohr, the nucleus of an atom is situated at the center. Is it correct? Yes. According to Bohr, he proposed that the nucleus of an atom is located at the center part of the atom. Around that, electrons are revolving in concentric circular paths. So this is correct. Next, according to Bohr, an electron neither loses nor gains energy when it jumps from one orbit to another orbit. Is it correct? No. When electron jumps from one orbit to another orbit, energy changes occurs. If electron jumps from higher orbit to lower orbit, it radiates energy. If the same electron, if it jumps from lower orbit to higher orbit, it absorbs radiation. So energy changes occurs when an electron jump from one orbit to another orbit. So here statement 1 is true, whereas statement 2 is false. What will be correct answer now? This. Okay. Next, analytical approach type questions. See the first one among these. A beam of alpha particles is fired at a piece of gold foil as shown below. After striking the gold foil, in which direction do the most of the alpha particles travel? Actually, this is a Rutherford's alpha ray scattering experiment. The same has been done in that also, isn't it? Rutherford taken a very thin gold foil and he taken a source of alpha particles. He made these alpha particles coming from the source to fall on the gold foil and to observe what is happening after striking the gold foil. He arranged a screen around the gold foil. Then he observed most of the alpha particles after striking the gold foil, they passed through the gold foil without any deviation. Most of them directly passed through the gold foil. So if you observe here, they have mentioned here the direction of the alpha particles in different ways. So most of the alpha particles pass directly through the gold foil in the direction P, because it is observed most of the scintillations occurred at this position. Because this is because of the most of the space in the atom is empty. Because of this empty space, these alpha particles passed through the gold foil without any deviation. Now the answer will be P. Next, the diagram given below represents the atom of an element. Now, which symbol gives the above information? Observe once the fundamental particles mentioned in that atom. How many electrons are there? 4 electrons are there. And number of protons? 4. So it is a neutral atom and with atomic number 4. We know the element with atomic number 4 is beryllium, isn't it? Beryllium. And if you observe once the number of protons and neutrons, total it is 9. That represents mass number of that element. So mass number is now 9, atomic number is 4. For this is for beryllium. So where it is mentioned with atomic number 4 and mass number 9. See here it is. Okay, this is the element which is representing the diagram. Okay, next one. See here two species are mentioned, A and B. Their fundamental particles numbers are also given in the tabular column. Observe once. So what relation between these two they have? A and B. A and B, if you observe, A and B both are having same number of protons, but they have different number of neutrons. Now these two we can say these A and B are having same atomic number but a different mass number. The atoms which are having same atomic number but different mass numbers are defined as isotopes. Now we can say this A and B are isotopes because they have same number of protons, hence we can say they have same atomic number, but they have different number different number of neutrons, so they will be having different mass numbers. Okay, they are called isotopes. Next one. Which of the following is true regarding the size of the orbits? How the size trends from lower orbit to higher orbit? We know the size of the first orbit or the orbit which is very near to the nucleus is very small, and as we move away from the nucleus the size of the orbits gradually increases. So we see the diagram which is representing the gradual increase in the size for the orbits from lower orbit to higher orbits. Which is the lowest orbit? First orbit, K shell. So K, L, M, N and so on. So the increasing gradual increasing should be from K to higher orbits. Where it is? Here it is mentioned. K is having lower size and it is gradually increasing to the outer orbits. Next. So that is about the level 2 practice sheet on the structure of the atom chapter. Okay. Thank you for watching our video. Please subscribe our YouTube channel Aims Today and visit our website aimstoday.in for latest updates and recorded videos.